Okay, so we want to determine the coordinates of the local maximum of fx. So here's our three graphs of these functions above here. You can see what we're trying to find. This is our original function. We want to find the maximum. So we're looking for that point there. What's its x value? What's its y value? Now that translates over here to this graph as this point here. So we want to find when the second or the first derivative is equal to 0, and then we're going to plug that into the other function to find out what y is when that happens. So they've given us the first derivative here. We're going to use null factor rule to work out what those intercepts are. So 0 is equal to x, 2 minus x, e to the power of minus x. What's going on here? Minus x plus 4. So first one is going to be that. Then we'll have 0 is equal to 2 minus x, which means that x is equal to 2. The other one is going to be equal to 0 minus x plus 4. Take this over by doing ln 0, we get a math error. Therefore, that one doesn't work. That one has no solution. So therefore, our answer here must be this one, because we don't want that one there. It's giving us a minimum. Okay, so now I'm going to take my answer of x plus 2 and I'm going to chuck it back into this one, our original one. So f2 is equal to 2 squared e to the power of minus 2 plus 4 is going to give me 4e to the power of 2. And that is where our y coordinate is. So if we're going to state this as a coordinate, it's going to be 2 and 4e, 2 like that. And that is the coordinate of our local maximum. Okay, so now we're going to use the second derivative to verify the nature of the stationary point from 15a. So we're going to plug it in. So into the second derivative, we're going to put in that point 2. Now, what it should tell us, if it's an unhappy face, meaning goes to a maximum, it should give me a negative answer. If it's a happy face, going to a minimum, it should give me a positive. If it's a stationary point of inflection, it will be inconclusive at that point. So yeah, that's what we're testing for. Okay, so I'm going to scroll back up and grab a little sneaky screenshot of these so I can just throw them around wherever I want. And then we're going to go back down here. Okay, so I'm just going to chuck my answers, or I'm going to chuck 2 into this. Okay, so chuck 2 into the second derivative. 2 squared minus 4 times 2 plus 2e to the power of minus 2 plus 4. That's going to give me 4 minus 8 will make minus 4 plus 2 is still minus 2e to the power of 2. So that's a negative. So second derivative at that point is negative. Therefore, f dash dash x is the little one eats the bigger one. So you could call that concave down, or you could say that it is maximum turning point. Determine the coordinates of any points of inflection. So to find a point of inflection, I let the second derivative equal 0, find out where that point is. So 0 is going to be equal to x squared minus 4x plus 2, e to the power of minus x plus 4. So null factor rule, I just let each bracket equal 0. Okay, so now I'm looking for two numbers that add to give me negative 4 and multiply to give me positive 2. So the numbers that multiply to give me 2 are 2 and 1. So that's not going to work for any of them. So we might have to use quadratic formula to work that side out. Okay, let's try the other side and see if that's going to be fast. So e minus x plus 4. So I take e to the other side. That one's going to give me ln 0, which is a math error. So that one's not going to work. So we're looking for our two solutions here. So let's chuck them into the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Good. Now, you should be singing that song to yourself to make sure that you don't forget it because it's an important one. So let's simplify what we've got. We've got 4 plus minus. The denominator here is going to be equal to 2. Inside of our bracket, I'm going to have 16 minus 4 times 2 is 8 minus 8, so that's going to be 8. So plus minus root 8. Now this can be simplified down to 2. This will cancel with this. And then 8 can be expressed as 2 to the power, or 2 root 2. So that can cancel out with that one. Plus minus. So it can just be 2 plus minus root 2 would be our two solutions. If you're having trouble with this, then you need to practice your quadratic formula a couple more times because it's definitely a good one to know. Okay, so we're going to determine the intervals now where f of x is concave up and concave down. So I found my 2 points of inflection. Let's just jump back up to our picture. So we found out that x is at 2. X is at 2. There'll be a point where it changes concavity, so that means that it's going from a max to a minimum. There's a point around there, which would be the 2 minus root 2. And then there'll be one over here somewhere at about 2. What's that? 2 plus root 2. So if you're looking at our picture here, it's pretty easy to see where it's increasing and decreasing. So before it, anywhere before, so when x is up to 2 minus root 2, all the way, any value before that, up to that point, it's going to be concave up. And then after that, between 2 minus root 2 all the way up to x, up to 2 root 2, it's going to be concave down. And then after that, anywhere after that, 2 plus root 2 is going to be concave up again. Okay, so we have two different parts there that are concave up and concave down. You'll obviously need to set this out nicer, but trying to write this on my little sketch pad is an absolute nightmare when you need to see the pictures.